how you can actually implement a quick model directly using MLlib. I'm not going to go into why we should be using MLlib specifically, because you might think like, oh, MLlib is basically just another package similar to scikit-learn and so on and so forth. But there are very specific reasons why you would want to use that. And one of those would be that, let's say you want to have the ability to scale, okay? And you want to leverage Spark for pre-processing and feature generation so that you can basically reduce the amount of time that it might take to actually produce training and test sets from a very large amount of data. And that would be like one use case. And another one would be, for example, when your input data or the model size becomes way too difficult to actually put on just one machine, and therefore you want to use Spark to actually do the heavy lifting. So these two use cases are very specific for using Spark, and you will find that the more projects you work on, you will have these type of issues, and then Spark can actually help you with that. And therefore, let's go right ahead and see how we can actually use Spark to create, in our case, a logistic regression model. But first, I'll just go through the steps that we will be basically going through in our implementation. So we're going to be loading a data set, a synthetic financial data set from Kaggle, and we're going to check the data types. And based on those data types, we're going to decide what type of feature preprocessing we need to do. And in our case, we're going to just need to do one-hot encoding for one feature, and then afterwards we can actually train the model, and then we're going to check some statistics on that as well. So let's go ahead and start working on it. In this first step, basically I'm just creating a Spark session, as you can see, and I'm just importing types and functions. And let's check the version of Spark, and we have version 3, which is the latest at this point. Let's go ahead now and load the data set. It's basically a synthetic financial data set from Kaggle. You can check the data set here at this link. So go ahead and download that. And basically what I've done, I've just randomly sampled 10% of the data set so that it loads faster. But of course you can use the full data set. And read this this file, and let's print the schema so we see what we're dealing with. So now we see all these features, and we have the feature is fraud, right? So basically this is our target, and these are our features. Let's check the data to see. I'm just printing 2 rows, and you can see we have type, amount, name, origin, and so on and so forth. It's a binary target. Let's just select a couple of features, because just for the sake of this tutorial, it's actually easier to just work with a smaller number of features. And I selected the type, amount, old balance, and new balance. And of course, the target as well is fraud. Let's see the new data set. And now we just have these features. Now, when we look at it, we can see that type is a categorical variable, and therefore we're going to need to do some pre-processing here. Amount, old balance, and new balance, these are continuous, and they seem to be in the same scale. Therefore, we won't need to do any sort of pre-processing here. But let's go ahead now and see how we can leverage MLlib to actually do the heavy lifting if this would be a very big data set. The first thing that we need to do is split the data into a train and test set. And because here we don't have, basically this data set doesn't have any sort of order in it, we can just split it randomly. Of course, if we would have some sort of time series, then random split wouldn't work, and we would need to use ranking, and then splitting the data set a little bit differently. But because here we don't have any time series, we can just use random split, and we're going to split it in 70% will be train and 30% will be the test set. And of course, I'm just setting a seed so that we can reproduce this train and test set accordingly, right? So let's see the length. So we have 445,000 records in the train set, and almost 200,000 in the test set. And of course, if we check the train, basically the train set is exactly like our original data frame, right? What we need to do now, and we already observed when we saw the data, basically we need to check the data types, because any type of string is treated as a categorical variable. But sometimes we might have numeric features that we want to be treated as categorical and vice versa, right? Now for us, it's pretty straightforward. We only have a string column. We can see that all the other ones are continuous. But this is something that you have to take into account, right? Because you might have numeric features that actually might be categorical. So not only string variables will be categorical. So we need to carefully identify which columns are numeric and which are categorical. And let's check the D types for our train set. And we can see that the amount old balance and new balance are doubles, which is okay. And we have the type, which is a string, okay? And therefore we need to actually select the categorical columns and the numerical columns. And therefore we're just doing a list comprehension here, in which we check whether the data type is string, and then we add it to the list. And the same for the numerical columns. We check for double, right, which is the type double, but the column name is fraud, because we only want to include the features that are used as predictors. So let's run this, and we can see that our numerical columns are amount, old balance, and new balance, and our categorical columns are formed out of just type. So for this reason, we're going to be using a Spark transformer, basically one-hot encoding. And a high-level concept of MLlib is that you need to use transformers so that you can convert some raw data in a certain way. And one-hot encoding is one transformer that we can actually use so that we transform our columns in numerical representations that can be understood by the machine learning model. And one-hot encoding requires first to do indexing, right? To use string indexer, as in our case, that converts a single feature first into an index feature. And normally, if you would have some sort of ordering, you can just use the string indexer, so you can just transform it into an index, so that you already have it in a numerical form. But what string indexing does, it actually adds ordering. And when it comes to machine learning models, you don't want to assume a specific type of order where there is no order, right? And therefore, one-hot encoding actually does that. It actually helps you transform those indexes into vectors formed out of zeros and ones, right? Rather than using it as an ordered numerical, basically, list. So, of course, you can find out more about one-hot encoding on these links, and of course about the string indexer that converts basically a feature into an index feature. Just check out these links and you can find out more about that. But I'm sure that you already know about one-hot encoding, and yeah, I just wanted to make it clearer again so that you have an understanding why we actually need to first use string indexer and then one-hot encoding. Let's go ahead and actually see and count the distinct types for our type feature. So we can see that it's categorical. We have 5 categories, and if we actually check to see their names, we can actually see that we have 5 categories and we have transfer, cash in, cash out, payment, and debit. And these are the counts for each type. Okay. Of course, you can use these aggregation and grouping so that you can actually check the value counts. It's actually easier to do it in Pandas. You can just use value counts, but here you actually have to group by and then count and of course then show. So what we're gonna need to do, we're gonna first import one-hot encoder and string indexer from ML feature. And basically how we're going to use the string indexer, we're going to create a list comprehension for each column in the categorical columns. And if we check it now, let's run this. You can see that we have only one string indexer because we only have one categorical column. And we're going to do the same for one-hot encoding. We're going to have a list comprehension and we're going to one-hot encode all the string indexed columns in categorical columns, and we're going to output them to another feature, basically the name of that column and one-hot encoder. And if we check this as well, we can see that we only have like one one-hot encoder because we only have the type column in our categorical columns. Now the next thing that we need to do is assemble this vector so that it can be used by our machine learning model. Because in Spark, you actually need to transform all of your features into just one feature that is a vector consisting of all of the features that you want to be added into the machine learning model as predictors. And vector assembler does this because this is the case in most classification and regression algorithms. You want to get your data into a column of type double, so that this is the way you actually represent the label. And then you also need to have a column of type vector, right, that represents the features. And this is what vector assembler does. It transforms those features into that specific vector type column. So we're going to import vector assembler, and let's set the inputs for the assembler. So we're going to have first the numerical columns, and because we didn't do any transformation on the numerical columns, because they are already in the same range, so we're not going to need to standard scale them or something like that. Basically, we can just add them as they are. And for the type column, we're going to add the one-hot encoded version of that column. And we're going to do that. And if we check the assembler input, we can see that we have the amount, we have the old balance, new balance, and then of course we don't have the type. We have type underscore one-hot encoder because we have the one-hot encoded version of the type column now. And we can easily assemble that vector by providing the input columns and then the output column. And we have the vector assembler features column that will consist of all of those inputted features into a vector type, as it's required by any classification or regression problem in Spark. Now that we have this vector assembled, we can actually use this to create a pipeline. And the pipeline is another high-level concept in Spark that actually helps you build a full pre-processing pipeline and, of course, model training as well in Spark. And it's something similar to scikit-learn's pipeline as well. Therefore, it should be quite easy to understand the concept. Basically, all of these pre-processing activities and so on and so forth, and model training activities, you can pass them as stages in that pipeline. And all you need to do is basically fit that pipeline in order to train the model. In our case, basically, I'm just going to use the pipeline for the pre-processing part, and therefore I'm going to add the stages. So first I'm going to add the string indexer, the one-hot encoder, and then the vector assembler. Okay, and I need to add the vector assembler as a list. So we can actually check the stages. So we have 3 stages. We have, first we do the string indexing on the columns that we specified in the string indexing. So we're not doing string indexing on all the columns. We're just using the string indexing from here, and we only have, right, the columns in the categorical columns. And then we're doing one-hot encoding in the same way, and then we assemble the vector as per our specification here. So now what we need to do is just import pipeline, and then we can set the stages, and then we fit it on the train set. And then we will transform the test set, because we will first need to fit on the train and then transform on the test set, because the test set is unknown to us, right? That's why we're using a test set. Okay, if we would fit on the full data frame, then we would be fitting on something that we don't really know, right? The test set is specifically so that you can test whether the model will actually perform, right, in the way that we want it to. And that's why we want to have an unseen data set, which is our test set. Let's do this. And we fit it on the train set, and then we transformed the test set. And let's select and see our data frame, our data set now. So you see we have the type, amount, old balance, and new balance. And then we have our vector assembled features that we're talking about, that consists of basically a vector consisting of the type, amount, old balance, and new balance. But as you can see, our type is basically one-hot encoded. Okay, so our type is formed out of this vector that consists of zeros and ones, and we have a position. The one is positioned based on that implementation. So this is basically how you actually one-hot encode and how you create a vector out of the features that you want to pass into your machine learning model. And the next step that we're going to do, we're going to train a logistic regression on the vector assembler features. But before we do that, I would like to thank you for visiting our channel and for subscribing to us. We have videos about basically applied data science projects that you don't really find in many places. We try to actually bring a practical way for you to learn data science rather than just going through all the mathematical concepts and all that stuff, because that makes it quite hard to get started with machine learning. And therefore, our goal here is to actually help you learn machine learning by actually doing, right? Not just learning concepts, but actually doing in the real world. Okay, so thank you again for visiting our channel, and don't forget to subscribe and definitely stay up to date with what we post. Okay, so let's go back, and I'll go ahead and train a logistic regression model on our data. So of course we import from ML classification, we import the logistic regression, and we're going to use for our data, right? We're going to use the vector assembler features, and we're going to have to name them features. This is a requirement from Spark. And we're going to use isFraud, the column isFraud, as the label, okay? Because Spark requires a column which is of a vector type called features, and the column of double called label. Okay, that's why we need to rename our columns to features and labels and label. Let's go ahead and do that. And if we check our data, we can see that we have features, which is exactly as earlier. We have a vector formed out of the features that we want to be added to our model, and then the label that is to be predicted. So we're going to fit our data to this logistic regression model. And then we can actually see the end area under, and now we can actually check a model summary, which is the ROC curve, and then we can actually check the precision and recall by accessing these metrics from model summary.